Number 2 then from the 2010 Higher Maths paper 2, there you are, wave equation. It says express, no it doesn't. It says this can be expressed in the form of k cos x plus a. And all it really says is calculate the values of k and a. It doesn't actually say write it out like this, but you would anyway at the end. Now it's in degrees. You might think degrees, phew, that's easier, but it's actually a pest. Although you're not penalised if you put it down in bad form, which we all do all the time anyway, because it's such a nuisance writing the wee degree signs in. So what is this then? Expand this side. Well, the cosine of the sum of two angles breaks into cos x cos a minus sin x sin a. Oh, does it? No, it's all in degrees. Strictly speaking, you should be putting all these wee degree signs in. Such a pest. If you don't, you wouldn't lose a mark. And then I like just to tidy it all up to have explicitly the coefficient of cos x and the coefficient of sin x, so you can compare the corresponding coefficients. So that means I've got k cos a times, oh, I don't know why I wrote that, times cos x minus k sin a times sin x. And then after all that, that's just 1 mark. Next part is compare the coefficients. For cos x, that says 12, so this should come to 12, so I can state k cos a equals 12. For the sines, negative 5 is the same as negative that, so the negatives are both the same, so k sin a is 5. I think I'll put that on top. K sin a is 5. Now that's the second mark for having both of those correct. So there's only 2 marks left, one for working out k, one for working out a, and it doesn't actually care how you work them out, it's only for the answers without any process. I prefer to actually be a bit more explicit and say and explain why it happens. That's a pair of simultaneous equations. The way you can isolate k is by squaring the pair of them and adding them. If you do 1 squared plus 2 squared, then you'll have a common factor of k squared. And that'll be times sin squared plus cos squared, which becomes 1. So k squared is 5 squared plus 12 squared. Now you could go through that. 25, 144, 169, root 169, 13. Or you might say, I recognise that. That's the 5, 12, 13 triangle. So you could jump straight to it. K equals 13, and I'll put the reason down. It was a 5, 12, 13 triangle, but they don't really care, because they only want the answer to k with no justification. Similarly for a. How would you find what a is? Well, if you took equation 1 and divided it by equation 2, the k's would cancel, sine over cos becomes tan, so you'd have the tan of a equals 5 upon 12. Now, a little check as to what size this angle might be. The sine was positive, because k was positive, so all sine tan cos, the sine is positive. The cosine is also positive, because k is positive, so the cosine is positive here and here, which means you are in the first quadrant. You're looking for the angle between 0 and 90, so that will be the one that comes out of that. So a will simply be the inverse tan of 5 upon 12. So typing that in, 5 over 12, no need to bring that down to a decimal, just leaving the raw form, and you get 22.619, etc. Just call that 22.6. Oops, I was about to put in degrees. But A is just the number of the degrees. The answer, strictly speaking, is just 22.6. I can't put 22.6 degrees in here, because then I'd have 22.6 degrees. Still, you're not penalised if you miss out all the degree signs and put it in at the answer. Strictly speaking, that was worth 1 mark, no matter how you got there. And this was worth 1 mark, no matter how you got there. Let's put that wee a back in. And that's all the question said. Find the values of k and a, but you can't resist. I'll put down the final result here. 12 cos x minus 5 sin x actually is 13, and don't leave it as root 169, 13 cos x plus 22.6 degrees. I'll underline that as if it was an answer, but they didn't ask for that. Now, there is one little check in case you make a mistake somewhere with identifying your signs as to the size of this angle here. Because after all, you might go through the routine of your cast diagram to identify where it is, but that's no use if you made a mistake with your signs in this expansion somewhere. But I'm going to do the naughty thing, which you're not allowed to do in the higher, but which is what you would do anywhere else, which is use phasors just to get this result. 12 cos as a vector is a vector pointing up the way of length 12. As that rotates, it generates a 12 cos x curve. Minus 5 sine is a vector pointing back from the horizontal of length 5. And then as that rotates, the resultant vector is this one here. So you can see from this diagram, remember that's cosine and that's negative sine. How could you reference this vector to a sine or a cosine? Well, it's just a small acute angle ahead of the cosine. The appropriate one for this would be so many, and it's obvious what the number is. I shouldn't use that triangle since I want this angle, because that's a 5, 12, 13 triangle, so that length is 13. And what's this angle? Well, the tangent of that angle is 5 up and 12, but the important thing is it's an acute angle ahead of the cosine, so you're looking for an answer which is less than 90. But that little triangle would answer the whole question. But don't do it, but by all means put a quick sketch just to check you've got your angle correct. Phasors. So what's part B for 3 marks? 1. Hence state the maximum and minimum values of this. No alteration of it, which you usually get, you know, like maybe doubling it or maybe adding some number onto it. Well, if this produces this single curve with an amplitude of 13, it's got a phase of 22, that just affects its position sideways. It's still just 13 times a cosine. I can say straight away the maximum value will be 13, because our cosine will go up to 13, and the minimum value will be negative 13. And determine the values of x at which these will occur. Remember, this is just the cosine curve, which goes up and down 13, which has been shifted back 22 degrees, or 22.6 degrees. And it just says state, there's no working required for this. So you could just put a sketch down and say, well, that would originally have been at 13 at 0, but if I put that back, it's going to go to negative 22, so that's out of range. This one here would have been at the top at 360, so you could say this. The maximum of 13 when x equals, and that will be 360, and it's going back 22.6, so it'll be 337.4. And the minimum of negative 13 when, now the minimum would have happened here, that would have been at 180, when x is 180, but it's been shifted back 22.6, so that'll be at 157.4. That was do it just by interpreting the graph, looking at the pictures of the answer. You might have decided to do it algebraically from that expression and say, well, that expression will be at 13. You could say maximum will be 13 when the cosine part is equal to 1, when the cos of x plus 22.6 degrees equals 1. And that happens when cos of x plus 22.6 equals either 0 or 360. And from that, that means x equals, now taking that off of that makes it negative, and then we're back to this. 360 minus 22.6, which is the 337.4. And similarly for the minimum. Say, oh, the minimum's negative 13. How could that possibly happen? Well, the cosine only goes up and down 1, so that must happen when the cosine gives you negative 1. So when the cosine of x plus 22.6 degrees is negative 1. When does that happen? That should happen when the angle is 180. So that means that happens, in this case, when it's 180 minus it, so that's the 157.4 again. So you could have done it, if you like, algebraically, or you could just have done it geometrically, because there was only 1 mark for the answer for each part. But what you shouldn't do is do it by differentiation, because differentiation is only defined in terms of radians. So if you tried to differentiate it, you wouldn't get the marks for part 2. You'd still get these two, the 213s, but not the marks for part 2.